I hope you have practiced some of the second quantization that I gave, okay, for the wave function. So, and then we wrote the operator. Please see the derivation of the anti-commutation rules, the definition of the annihilation operator in relation to the creation operator. Why is it adjoint? Okay. And of course, the important thing is AI-AJ dagger, that is the only difficult part. Okay, please see the derivation of the anti-commutation. Look at the exercise, because we are not going to do lots of problems, but I can give from the Szabo and Oslund a few exercises for practice. Again, you should do that. So, for example, A1 A2 dagger plus A2 dagger A1, this is something that you can just practice. Okay, you can actually use the anti-commutation rule on any determinant k is 0. So, you can take determinants like k equal to chi1, chi2, chi1, chi3, any determinant you can take, and so on, 2 electron determinant. Just check that this is 0. Obviously, it has to be 0 because of the anti-commutation, and if you do, let us say A1 dagger plus A1 dagger A1 on any of these ket, it should be equal to the same ket. Okay. So, that is very important to realize, any ket. So, the ket may not have chi1, so it can be chi2, chi3. So, do not get confused, chi2, chi4, anything, because that is very important, because you may be confused that how A1 dagger when k does not have chi1 is still, why it is not 0. Okay. I hope you understand that if you have, let us say, chi2, chi3, I first create here and then I destroy. So, I get back the same ket. Okay. So, first I create an n plus 1 electron state, although chi2, chi1 was not included here, I first create a chi1, chi2, chi3, then I destroy. So, I get back chi2, chi3, and of course, this is 0. So, one of them will survive depending on if that particular orbital is absent or present. So, there is sometimes people get confused that if the determinant does not have these orbitals, how can this act? You may think this is always going to be 0, because you have A1 dagger. If determinant does not contain A1, it will first create and then annihilate. Okay. So, you get back the same determinant. This will not act, of course. So, remember, this is an anti-commutation. So, just practice this so that you will understand the anti-commutation properly, what this anti-commutation means. Okay. After that, we gave the form for the two operators. So, one is theta 1, one is theta 2. Operator form, we are not going to derive it, but let me write down the operator form. So, one was the theta 1, which is sum over, in first quantization it is sum over h of I equal to 1 to n. So, this is the first quantized operator. In second quantization, this theta 1 will be written in terms of basis alone. So, that is important to realize, that you will now have only basis by which it will be written. So, sum over all bases ij, iij, and you have ai dagger aj. So, one of them will be, so the standard definition is that one which is on the right side is created, one which is on the left side of the matrix element is annihilated. That is the standard definition. So, please follow this. All right, otherwise everything will not come, first quantized formulas will not come. So, in the same way, if I write theta 2, which is sum over 1 by Rij, it is a 2 electron operator in first quantization. So, these are all in first quantization. Okay. So, what I am writing is second quantization. Note that in this case ij's are now spin orbitals, they are not coordinates of the electrons, quite obviously, because I am using this is ai dagger, aj, etc. So, they are no longer coordinates, they are actually the spin orbital basis. So, that is the beauty of the second quantization, that number of electrons, as I told you before, that this actually vanishes. So, the theta 2 then becomes here half of ijkl, and then there is an integral which is the regular integral ijkl, and then you have operators which create ij, annihilate kl, and the specific order is ai dagger, aj dagger, al, ak. That is the specific order. So, first k is annihilated, then L is annihilated. In the place of L, J is created, because that is what it means. In the place of L, J is created. Okay? Remember, this is a Dirac notation. So, this means I star 1, J star 2, 1 by R 2, K 1 L 2, right, delta 1 delta 2. So, obviously, you can see that wherever the L was there, that must be replaced by J. So, that is the reason immediate annihilation, immediate creation, and then wherever K was annihilated, I will be created. So, please do not write AI dagger, AJ dagger, AKL. So, that is what I am just, there has to be a switch here, AL, AK, because of the, so this is the second quantized form of theta 1, theta 2, in which these are all bases. Okay, these are all bases, exchange is not there. So, second quantized notation has only the 1 by R 2. So, that is what we will show how the exchange term comes. Okay. Using the anti-commutation, we will see how the exchange term comes. Okay. The anti-commutation will automatically bring the exchange term, because whenever I write AI, AJ dagger, delta, IJ minus, it will come. So, first thing to do is, let us say theta 1 in first quantization, H of 1 plus H of 2. So, again just a simple 2 electron problem, okay, and you have a given determinant. So, let us say my psi 0 in first quantization is chi 1 chi 2. Note again, these 1 and 2 are spin orbital, these 1 and 2 are coordinates. I am again repeating, do not confuse with these 1 and 2. Okay, this could have been chi 3, chi 4, anything. So, these are spin orbitals, these are coordinates. So, this can be written as A1 dagger, A2 dagger, vacuum in second quantization, right. Now, we know that this psi naught, theta 1, psi naught, what is the result of this? Yeah, I have just given you, it is a 2 electron problem, you do not have to sum. Yes. So, H11 plus H22. So, this is something, the result that we know. Again, 1 and 2 here are not coordinates of electron, they are spin orbitals, because coordinate of electron becomes now dummy, that is going to be integrated. So, now let us apply the second quantization to show this. So, what do you have to do? You have to write this as a vacuum. First, you write the left psi naught vector. So, it is vacuum A2 A1. So, this is a specific index, remember. A2 A1 is a specific index 1 and 2, which are actually present there, and then you have to write theta 1. So, what is the expression of theta 1 is sum over ij. Okay. So, you have a sum over ij now, dummy index, then you have a ai dagger aj, all aij, ai dagger aj, and then again a1 dagger, a2 dagger, vacuum multiplied by the matrix element hij. So, hij I define as IHJ, correct. Okay. So, A1, A2 are occupied orbitals, they are very specific. Ij of course contains these occupied orbitals, but they contains everything else, because it is a sum over expansion of the basis set. Now, practice this again, how to manipulate these quantities. First of all, you have to remember the whole idea of manipulation, that you must try to bring the annihilation operator to the right, because moment it acts on vacuum, that will become 0. But to do that, you can see that first you have to anti-commute this aj a1 dagger, bring aj here, then anti-commute aj a2 dagger, bring aj on the right. Each of these anti-commutation will actually, for example, what will be the anti-commutation of aj ai dagger? this will become delta J1 minus A1 dagger AJ, right? So I bring AJ to the right. Now delta J1 would automatically ensure that now my summation J must be equal to 1, otherwise this term drops out. Okay, so when you now manipulate, make sure that your J is equal to 1. Okay, otherwise this term will drop out, it will become 0, and then only A1 dagger AJ remains. Then you manipulate AJ A2 dagger, another delta condition will come, okay, and just show that eventually what you get is simply H11 plus H22. So basically eventually I must be equal to J and they must be either 1 or 2 with the delta AJ condition. So this requires a little, but I just thought I will give you some practice problem so that you can do this. The other way sometimes simplification is that do not expand psi naught, keep psi naught as it is, only expand theta 1 in terms of the basis, and then let the orbitals act directly on psi naught. So you can get an expression like, so some psi naught A dagger AB psi naught, you can anti-commute and you will get this as delta AB psi 0 minus psi 0 AB A dagger psi 0. And then since A dagger is a occupied orbital, it will act on the psi naught to give you 0. Okay, so if you write this in terms of occupied orbitals, but I think right now I will introduce this particular vacuum which will make it simpler. You can right now try with this full expansion for the theta 1 at least. Theta 2 I will not ask you to do, but he had a question how the antisymmetric integral comes. That is because when I start again anti-commutating, 2 terms will come. So that is going to give you the antisymmetric integral finally. Okay. So this is only for you to test that this is self-consistent to your first quantized notation, because we are not proving it ab initio, we are giving you the expression and then you can check that they are self-consistent. At least for one term you should be able to do this. Okay. Yeah, you can also practice similarly problems like, yes, the following problems on singly excited determinant. Note that many of these problems are given in the text, in the Zabos-Lund. So please read this. So for example, if you have a psi AR theta 1 psi 0, so show that it is equal to R AJ, exactly in the same manner. You can show that it is equal to R AJ. Many of these you can actually show by keeping psi naught as it is, that is without even expanding psi naught. So this particular problem is not a 2 electron problem, it can be anything. So you should be able to write, how will you write psi AR? As AA, AR dagger, AA on psi 0, right? Can I write it other way around? Why? What is the difference? Because the other one was there? Yes. What will happen if I create first and then annihilate?
Then it becomes minus because it's anti-commutative.
I know, but what happens to the determinant? Think in terms of determinant. If I first create, the R would come here, right? And then the rest will remain. Then I annihilate AA. So chi A is somewhere here. Chi A will be somewhere here. So how do I annihilate? I have to first bring it here. So I have to make this minus A, chi A, then chi R will go here and the rest will there. So then you get minus the same determinant with chi R. So you can see I started with the determinant where chi A was here. I am getting chi R but with this minus sign, right? So I am just trying to show why it is not, I mean your point is right. It is also expression of anti-commutation actually. Okay. So but on the other hand, if you do AR dagger A, okay, if you do AR dagger A, then you first bring it here. So there is a minus sign, bring it to chi 1, there is a minus sign, then create AR, then you have to push it back there again. So that's why these two minus signs will cancel. So I will get, so one way to write this is AR dagger, AA acting on psi naught. Okay. So please make sure, these are all small problems, please make sure that you are able to handle. And this is actually clear from the anti-commutation that both cannot give the same wave function because they anti-commute. Okay. So if you start from psi naught without expanding, if you start from psi naught, remember A is an occupied orbital, R is a virtual orbital, that is all you need to remember. So if you finally get AA dagger acting on psi 0, that will become 0. Note that when you are starting from a general set of orbitals, what is our strategy? When you are expanding in terms of vacuum, our strategy is to get an annihilation operator to the right. The only difference here is that instead of vacuum, if you keep this psi 0, your strategy will be to bring AA dagger to the right, AA dagger, occupation, because then automatically this is 0. I hope that is clear, that is a killer condition. Okay. So you can start with psi 0 instead of expanding from vacuum, because if you expand from vacuum, you have to unnecessarily write lots of terms. Like for example, this 2 electron determinant, you have to write A2, A1 here, A1 dagger, A2 dagger here. So while you first try this, then eventually start to think in terms of psi 0 directly. That how do I write this expression in terms of psi 0 directly? So this expression in second quantization then will become psi 0 A dagger AR, psi AR. I will not write the whole vacuum whatever is there because it is too complicated. Then I write theta 1, which is of course AI dagger AJ, okay, and then psi 0, and you have HIJ, sum over all ij. Now you have to be a little bit careful. A is an occupied orbital, you have to remember. R is a virtual orbital. I and J can be any index. I and J, however, can be any index because that is coming from the expression of theta 1, which is any index. Now you must start to manipulate. So our idea would be to bring A dagger here. If you can bring A dagger to the right, that is 0. Okay. So try to do this and reach the result H RA. So basically R dagger will come here and A dagger will come here, A dagger will come here. So obviously when you are trying to quantize this, for example, this itself, you will have a delta Ri. So I must be equal to R, otherwise that part is 0, and you will have AI dagger AR and so on. Then A dagger, or you can start with here, bring A dagger here, A dagger, I dagger, and then eventually this. Okay. So start doing the manipulation. So these are some of the algebraic manipulation that you should be able to show. I have simplified this because I am not expanding psi 0. So if you don't expand psi 0, your killer condition becomes this: A dagger psi 0 equal to 0, where A is occupied orbital. Quite clearly, this is much simpler. Simply because I don't have to expand this. Here it was okay, you can do this for 2 electron. But if it is n electron, then there will be n sets of orbitals here, n sets of orbital here. So this becomes a horrendous task to keep manipulating, so that eventually all the annihilation operators one by one come to the right. Here all you have to do is to bring all the creation of the occupied orbitals to the right. Okay? And of course, if AR also comes to the right, it is okay, because that is also 0. So either you have to bring AR to the right or A dagger to the right eventually. Okay, so start doing this manipulation because each of them is 0. A dagger, AR psi 0 is also 0. If R is virtual orbital. So this is the 2 killer condition that we will use. And this is simpler because I am not expanding psi 0. Okay, please practice this. If you have problem on the final day, we will discuss some problems, okay, on Thursday, because I want to finish the course. Because now I am going to come to an important topic.